In this video, I'm going to show you how to use the MQTT protocol to collect OPC UA data from your factory floor, publish it to an MQTT broker cluster on Azure Cloud, and visualize the information using Azure Time Series Insights. So let us begin by looking at the architecture of our system. The challenge with collecting and analyzing OPC UA data on Azure Cloud is that, first, using a client-server approach to gather OPC UA data from Azure Cloud is a complex and non-scalable approach. Second, if you decide to use a publish-subscribe-based protocol like MQTT to publish OPC UA data to Azure via Azure IoT Hub, its cloud gateway service, then you won't get full MQTT functionality, as Azure IoT Hub is not 100% MQTT compliant. A better approach would be to deploy a standalone MQTT broker on Azure Cloud that will receive messages from your factory floor. So in our case, we're going to deploy a standalone MQTT broker on Azure Cloud in the form of a HiveMQ broker cluster. And at the edge, we're going to build a simple .NET Core application to act as a gateway that reads simulated OPC UA data from our Cape Server EX OPC UA server, converts the data to JSON, and publishes it to our HiveMQ cluster on Azure. We're then going to configure our HiveMQ broker's inbuilt Kafka extension to forward these MQTT messages to an Azure Event Hub service. And this is possible because Azure Event Hubs provides a compatibility layer for Kafka consumers and producers. And then from there, we'll add the Azure Event Hub service as a source to an Azure Time Series Insights environment where we'll be able to visualize and analyze the information from our OPC UA server. Simply put, this architecture allows us to use a 100% MQTT compliant message broker while leveraging powerful Azure data services for streaming, analysis, and storage of our factory floor messages. Okay, so we're going to begin by deploying our HiveMQ MQTT broker cluster on Azure Cloud. And to do that, I'll go to this HiveMQ GitHub repository, and here I'll select the ARM Quick Start templates. Then we go ahead and click on Deploy to Azure. So this will take me to my Azure portal where I'm able to customize this deployment. So here I'll leave my subscription account as default, and then I'll create a new resource group and call it HiveMQ Demo, and I'll leave the selected region as East US. Next, I'll enter my admin username for this deployment, which I'll call HiveMQ VM, and then under authentication type, I'll keep it at password and then go on to enter my password. Okay, next, I'll enter the current HiveMQ MQTT broker version. Now, by default, this custom deployment deploys 2 HiveMQ nodes for your cluster. So you could choose to deploy more or less. And for demonstration here, I'll use just 1 node for my cluster. Okay, and then I'll click on Review and Create. And then click on Create to start the deployment. Okay, so my deployment is complete. I'll go ahead and click on Go to Resource. Now, here you'll notice that a bunch of services have been provisioned for me, including a virtual machine, storage account, and load balancer, etc. Now, to get the public IP address of my cluster, I'll select the HiveMQ load balancer public IP. Okay, next, we need to access our HiveMQ control center to see if everything was successfully deployed. So here I'll copy the IP address, open a new browser window, and then put the IP address here with port number 8080. And then here I'll enter the HiveMQ default username and password, and then log in. Okay, as you can see, our HiveMQ broker cluster is up and running and ready to receive MQTT messages. Okay, next, we need to configure the HiveMQ Kafka extension that would enable us to send messages from our HiveMQ message broker to our Azure Event Hub service. So first, we need to access the configuration files that come with the installation of our HiveMQ cluster on Azure. And to do that, I'm going to use Party to SSH into our HiveMQ cluster node. So as you can see here, I need the IP address of my HiveMQ cluster. So I'll go to my Azure portal, under resource groups, select the HiveMQ demo resource group. Now if you remember, I only provisioned one node for my HiveMQ cluster. So here I can go ahead and look for HiveMQ node 0 IP address, which is HiveMQ node 0 public IP. So if I select that, I can go ahead and copy the IP address. And then I can go back to my party, paste the IP address, and then here I'll enter the login name, which is HiveMQ VM, and then I'll enter my password. Okay, so here first of all, I need to make sure that I've got root access. And then next, I need to go into the directory of my virtual machine that stores the application program packages. So this is where our HiveMQ broker would be installed. So that would be my opt directory. So I'll cd into that. And then here you can see we've got our HiveMQ directory. So I'll cd into that. And then inside our HiveMQ directory, you can see we've got a number of directories. So I'm going to cd into the extensions directory. And then inside the extensions directory, you can see we've got the HiveMQ Kafka extension. So I'll go into that. Okay, once I'm inside the HiveMQ Kafka extension directory, you can see that I've got a number of directories and files. So there are a couple of things that I need to do here. First of all, to enable the Kafka extension, I need to remove the disabled file. So I'll go ahead and do that. Next, I need to rename the Kafka configuration.example.xml file into just Kafka configuration.xml. So I'll go ahead and do that. I'll first clear the terminal, and then I'll enter my command for renaming the Kafka configuration file. And then we can go ahead and open up the file. Okay, so I've got my Kafka configuration file open. Now what I would want to do is to edit this file and include information about the Azure Event Hub service so that our HiveMQ broker knows where to forward information that is being published from the edge device. So basically, we're going to edit our file so that it includes this information here under Kafka clusters, which is the Event Hub namespace. And then here, we're going to put the connection string of our Azure Event Hub service. And then here, this is where we put our Kafka topic. And in our case, this would be the Event Hub queue name. And then here, this is where we put the MQTT topic that we're publishing to, which in our case is HiveMQ demo/telemetry. But first, for us to get this information to include into our Kafka configuration file, we have to first create our Azure Event Hub service. So let's go ahead and do that. Okay, so to set up my Azure Event Hub service and connect it to my HiveMQ Kafka extension, I'll go back to my home page here. And then I'll select on create a resource. And then here I'll type Event Hubs. And then here I'll go ahead and click on create. Okay, I'll leave my subscription here as default. And then here I'll select the resource group, which is HiveMQ demo, which we created earlier. And then here I'll enter the namespace name. I'll call it HiveMQ demo. And then under location here, I'll also select East US. And then here for my pricing tier, I'll select the standard and leave my throughput units set to 1. And then I'll go ahead and click on create. Okay, so my Azure Event Hub service has been successfully deployed. So I'll click on Go to Resource. Okay, once we've opened up our Event Hub's namespace, you scroll down here and select Event Hubs. And then from here, we can go ahead and create a new Event Hub queue by clicking on the plus sign here. And then here I need to enter the name of my Event Hub queue. Which I'll call HiveMQ Inbound. And then next I'll set the partition count to 5 and the message retention to 3. Okay, and then I'll go ahead and click on Create. Okay, so far we've created an Event Hub's namespace for our demo, and we've also created an Event Hub queue. A third item that we're going to need for use in configuring our Kafka extension is the connection string. So let's go ahead and get the connection string. So to do that, I'll go to Shared Access Policies here. And then here we're going to go ahead and create a new Shared Access Policy, which I'll call HiveMQ Extension. And then I'll check the Manage box and then go ahead and create. And then next we select this policy that we have just created, and this is where we get our connection string primary key, which we're going to use for configuring our Kafka extension. So I'll go ahead and copy this. Okay, now that we've got our 3 parameters, let us go ahead and include them in our Kafka extension configuration file. Okay, so I've gone ahead and put in the parameters that we got during the creation of our Azure Event Hub service. So as you can see here, we've got our Event Hub namespace, and then here I've got my connection string primary key. I've also got TLS enabled. I've assigned an MQTT topic filter, HiveMQ demo/telemetry, and I've also included my Event Hub queue as the Kafka topic. Now to check the health of our Kafka extension, we can go to the HiveMQ Control Center here, and then you can see we've got Kafka showing here. If I go to the dashboard, you can check here under current status, it says all checks successful. Okay, now let's go ahead and start publishing our messages to our HiveMQ cluster on Azure. Okay, so let me start by showing you my OPC UA server that I have running here. So what I have here is the CapServer EX software, which is capable of using multiple industrial protocol drivers to collect data and expose it using OPC UA. Now for our demonstration, we're not going to connect to a real device, but we'll use the simulated values that come with the software package. So if we expand under simulation examples here and select functions, you can see the simulated values of different data types. So our goal would be to access these values using an OPC UA client, which in our case would be a .NET Core application. But before we can do that, we need to get our OPC UA server address in order to connect to it. And for that, CapServer uses what is called an OPC UA configuration manager. So I'll pull it up here. Now, as you can see, these are our OPC UA server endpoints. The first one uses the loopback IP address, while the other one uses my PC name as the host name. So this server allows for anonymous connection. And if you're connecting to it for the first time, you'll need to select to trust your OPC UA client when it shows up under the Trusted Clients tab here. Also, make sure that access to port 49320 is allowed through your firewall. Okay, so our OPC UA server is up and running, but before we can build our application to consume this information, we're going to use a test OPC UA client from Process to make sure that our OPC UA server is accessible and view the live data of our simulated values. So I'll pull up my Process OPC UA client. So as you can see here, I have my OPC UA server address on the address bar. So I'll go ahead and click on connect. Okay, we've successfully connected to our OPC UA server. Now if we expand on objects here, and then expand our simulation examples, and then go to our functions, you will see our simulated example data. So to view the actual data here, I'll go ahead and right click on ramp 2 and then select monitor. And when I do that, we start to see our simulated values. And more importantly, we have the node ID of this value here, which we'll need to take note of, as we will need to use it to access this particular tag from our .NET Core application. Okay, now I'll head over to my Visual Studio to start creating our application for reading data from our OPC UA server and publishing it to our HiveMQ cluster on Azure Cloud as MQTT messages. Okay, so in this section, I'm going to show you how to build an OPC UA to MQTT Gateway using .NET Core and an OPC UA SDK provided by the OPC Foundation. So here I'll go ahead and create a new project. I will select it to be a .NET Core console app. And then I'll call this OPC UA MQTT Gateway. And then here I'll select .NET 5 and then go ahead and click on Create. Okay, so my project has been successfully created. Now the first thing that I need to do here is to install the OPC UA .NET Standard SDK. And to do that, I'll right click on my project here and then I'll select Manage NuGet Packages. Go to Browse, and then here I'll search for OPC Foundation .NET Standard.OPC UA. So I'll select that one and then go ahead and install it. Okay, so that's done. Next, for MQTT functionality on my application, I'll also need to add an MQTT package that works with .NET Core. So I'll go ahead and search for a package called M2MQTT for .NET Core. So I'll select that one and click on Install. Okay, so I've successfully installed the required packages. Now I'll go ahead and open up my main program C# file. Okay, so here first of all, I'll declare my variables. Here we have a variable for holding our node ID for our ramp2 tag. And we also have a variable for holding the actual ramp2 value. And then here I'm creating an OPC UA session instance, followed by the creation of my MQTT client instance with my HiveMQ cluster connection details. Now inside my main function, I begin by generating an MQTT client ID, and then I connect to my HiveMQ cluster on Azure, and then after that I call my function called start gateway. So let me go ahead and paste my function here. So inside my start gateway function here, I've got my code for creating an OPC UA application instance and its configuration parameters. So here we set our configuration parameters, which include our OPC UA application name, application URI, application type, which is client in our case, security and transport configurations. And then from there, we initialize our OPC UA application instance. And then we set our check application instance certificate to false. And then next, we specify our OPC UA server endpoint, and then initialize an OPC UA session with those configurations. And then here I have my loop that runs forever. And then inside my loop, I use my node ID to read the OPC UA ramp2 node. I then extract the value from the node and put it in my ramp2 value as a double data type. From there, I go on to create an object that we're going to publish via MQTT. So this object consists of a device ID property, which is plant A, and it consists of a ramp2 property, which is the actual ramp2 value that we read from our OPC UA server. But before we publish our object, we need to convert it to a JSON object. And then once that is done, I go ahead and publish my JSON object under the topic HiveMQ/telemetry. And then I delay for 5 seconds, print the output, and read and publish again. Okay, so that should be it. So let's go ahead and run our OPC UA to MQTT Gateway. Okay, so as you can see, our application is running and publishing values to our HiveMQ cluster, which gets forwarded to our Azure Event Hub service using the HiveMQ Kafka extension. But before we go ahead to check to see if we're receiving messages on our Azure Event Hubs, let's test to see if we are indeed publishing to our HiveMQ cluster on Azure. And to do that, I'll use a utility called MQTT.fx. Okay, so here I'm already connected to my HiveMQ cluster, so I'll go ahead and subscribe to this topic. I'll change the format to JSON. And as you can see, we are successfully publishing our OPC UA data to our HiveMQ cluster on Azure. Okay, so to check to see if we're receiving our messages here on Azure Event Hub service, I'll go to my Azure portal homepage here. And then I'll go to HiveMQ Demo Event Hub namespace. And then here under the overview, I'll just scroll down. And then you can see there we're receiving our messages. Now, for Azure Time Series Insights to be able to ingest information with no interruptions at all, we need to send a dedicated stream of information for it to consume. So to achieve that, we need to create a dedicated consumer group in our Azure Event Hub service that the Azure Time Series Insights environment can consume from. So to do that, we go to our Event Hub instance, which we called HiveMQ Inbound, and we click into it. And then here to the left, we select consumer groups. And then we create a new consumer group. And then we call our consumer group HiveMQ Demo Event Hub TSI Stream. So I'll go ahead and click on Create. Okay, so what this means is that we can now go ahead and create our Azure Time Series Insights service to start ingesting this information and visualizing it. And to create a Time Series Insights service, I'll go to create a resource. And then here I'll type in Time Series Insights. Select it. And then click on Create. Now here I'll leave my subscription as default. And then under Resource Group, I'll select my HiveMQ Demo Resource Group. And then next, I need to give my Time Series Insights environment a name. And then I'll change my location to East US to make sure that it's in the same region as my Azure Event Hub service. And then I'll leave the tier as default. And then next, here we need to create a time series ID. Now here your time series ID acts as a partition key for your time series data that is being published from our OPC UA to MQTT Gateway. In simple terms, the ID that you put here must be a property that is present in each of your messages that are forwarded to this time series environment. So since we expect to receive a JSON object with device ID as its main property, we can use the device ID as our partition key. So I'll go ahead and put it here. Now, creating a time series environment also involves creating a storage account. So I'll go ahead and give my storage account a name. And then I'll leave the rest of the stuff as default. And then I'm going to go ahead and click on Next, which is our event source. Now, this section here of adding an event source to your time series environment, you can even do it after provisioning your environment. But we'll go ahead and add an event source now. So under source type here, I'll select Event Hub. And then I'll give my source a name. And then next, I'll leave my subscription as default. And then here under Event Hub namespace, I'll select my HiveMQ demo event app namespace. And then under event app name, I'll select my HiveMQ inbound. And under event hub access policy name, I'll select HiveMQ extension. And then here is where we need to select our event hub consumer group, which I'll go ahead and select. Okay, so that's it for configuring our event source for time series insights environment. So I'll go ahead and click on next, and then we can go ahead and click on review plus create. Okay, so now the deployment of my time series insights environment is now complete. So I'll go ahead and click on go to resource. I'll go ahead and click on go to TSI Explorer. Okay, so automatically you can see that our plant A is being reflected here. And if I click into it, I can see other properties that are coming with that payload. So I'll go ahead and select ramp 2 and then click add to start visualizing it. And then I can also add event count. Okay, so as you can see, we are successfully visualizing our data that is coming from our OPC UA server via our OPC UA to MQTT Gateway.